changing internet protocol, the IP address, to a fixed physical machine address, also known as the media access control, the MAC address, in a local area network. So basically, it just resolves IP addresses to MAC addresses. It helps devices within a local area network to communicate with each other. This is how a typical network with an attacker looks like. So in this project, my whole purpose was to try and program a code that can do an ARP spoofing attack. An attacker being on a network is necessary for this attack to go through. In an ARP spoofing attack, this is what happens. ARP spoofing redirects the flow of data within a network. This puts the attacker in the middle of the connection, intercepting requests from the victim and intercepting responses from the router. So this image right here is how an ARP spoofing starts. A hacker sends both ARP responses to both the victim and the router. At the end of the day, this is how the connection will look once the attacker is successful. He has put himself in the middle of the connection, intercepting both responses from the router and requests from the victim. Now, why is this attack possible? ARP is inherently insecure. Devices can accept responses without even asking for one. There is no verification of the devices which send their responses, like saying, "Oh, look, I have the victim's MAC address, so see me as the victim." No, there's no verification if the device is an attacker or legitimate. The tools I'm using to replicate this attack is a virtual network, a virtual machine that will be the victim, Kali Linux, Python language to write an ARP spoofing program, and Wireshark to see if my code is working. The code breakdown: get a target and router information, send ARP responses to both target IP and router. Use a loop for continuous sending of packets, forward port number for seamless connection. This is how the code is going to operate. Now, okay. Here's the code I'm going to use to perform this ARP attack. We are importing time just so we're using it that's in the in the while loop, so we can continuously send packets with a 2-second timer. And we are importing Scapy. Scapy is a tool that's used for manipulating packets within Python. It's a module within Python that's used for manipulating packets. It can be used to send ARP responses. It can be used to um for different networking commands and other things based on networking. So we have well, the program is in three parts. The first function is the getMac function. This is basically just when I give it an IP address, it finds the MAC address. Is basically like an ARP tag A command on the terminal. So basically, I give it a specified IP address, and it broadcasts that IP address to find its MAC address. Basically, just what the address resolution protocol does. Then the second function is the spoof function. This is where I give it two specified targets, the target IP and the spoof IP. The target MAC comes from the getMac function, where and the packet variable is used escape is used to create the packet variable, while the while true function is used to spoof the both the target IP and the spoof IP. So if we're trying to see this code in action, this is how it will look. To confirm that nothing has been changed and the router's the router's physical address is still the same, we go to the victim machine and type the ARP tag A response. Now, as we can see, the router's IP is still the same and is not ours yet. It's not the same as ours yet. If we want to look at our own MAC address, we type the ifconfig command and we see our MAC address ends with 98. The the router's MAC address ends with 00. Now, if we were to run this command, okay, okay, the program is now running. Now, if we go back to our victim machine and type the same command again, we would see that the router's IP address is now our own 98. Now, to confirm that the program is working properly, right now I haven't forwarded my port number, so the victim machine should not have access to the internet right now. This code can also be used to perform a DOS attack. Yes, right now the code is running properly. Now, if I go to my terminal, my code, there's a comment down here telling me to use this command and type it into the terminal to forward my port number. So I'll just copy that, go to a terminal, paste it, copy. And now we should see at the here we see that the victim machine now has internet access. If we go back to the attacker machine and go to Wireshark, ETH0, we start capturing from ETH0, we can see that a lot of ARP protocols are being sent by my code right now. Anything that this victim does on the internet, I will be able to see it. As you can see, every every packet that the victim machine sends over, I can intercept it. If there's anything sensitive, I can intercept it and either modify it if I so choose, or drop it if I so choose, or right now that I have sent my port for, I've forwarded my port number, I can just be a passive listener and just be on the network seeing whatever the victim does. So this concludes my presentation for the ARP spoofing attack.